Alright guys, solve example 2.8, which I think it's this one. A car traveling at constant speed at 45 miles per hour passes a trooper on the motorcycle. It's hidden behind the billboard. 1 second later, after the speeding car passes the billboard, the trooper sets out from the billboard to catch the car, accelerating at a constant rate at 3 meters per second. How long does it take for her to overtake the car? So the way I'm going to solve this or set this up, it doesn't, not like it really matters, is, well, you can really set it up how you guys want, but I'm going to set it up the moment, but they call this t equals -1 second, but I'm not going to do that. I'm just going to put it at 0. So I'm going to define 0 as the time it takes where the position for both of them is going to be 0. So both the car and the vehicle is, so I'm going to let the car be red, and the car is traveling at a constant speed of 45 meters per second. So that's basically the equation in a nutshell. So this is going to be 45 meters per second times the time. So that's just going to be a straight line. And remember, folks, that this is the t-axis, and this is going to be the x-axis. And the trooper here is going to bypass the vehicle, but it's only until 1 second later, after the speeding car passes, that the trooper sets out from the billboard to catch the car, and it has a constant acceleration. So it's going to start from 0, and it's going to accelerate towards to catch the car. See how I'm drawing this, folks? Let me see if I can redraw this. So this is going to be the x-axis, and the billboard's going to be maybe like right here. Something like that. I shouldn't have drawn that a little that slanted, but oh boy. Something like that. As best I can draw, I guess. So this is going to be 1 second. And by then, the car is going to travel already at 45 meters. So at t equals that, at 1 second, this is going to be 45 meters. So the equation for the blue is going to be nothing more than this. Let me move this on the side here. In fact, let me put this here, and let me put this at the bottom. So the x is going to be so its initial position is going to be 0. Its initial velocity is going to be 0, and its acceleration is going to be at what is it? What does it say? 3 meters per second squared. So that's 3 meters per second squared divided by 2 t after 1 second square. So there you go, folks. Those are your two equations. The thing wants us to solve this graphically, but in order to graphically set it up, you could do that. And what you could do is you could take the +1 here and put it just a t there if you guys want, because it really doesn't matter. So how long does it take? So what you do is you let the time equal to each other. So in this case, I'm going to put 45 times the t equals 1.5. I'm going to leave the units off for a bit. So this is going to be t minus 1 square. Once you solve it, the t here is going to be 31.97 seconds, and the x is going to be 1.44 kilometers approximately. I'm just kind of converting there. It actually says 14348 whatever. So at 32 seconds, that's when they catch it. So right after, so at the position at t equals 0, so the answer is going to be 32 seconds or 31 seconds. If I think that's what the answer says. I don't remember, depending on how they describe the solution. But anyways, those are your two equations that you guys can graph on Desmos if you want, and then you can see that the answers match up.